Takes too long, doesn't it? Hello. No. Okay. You're welcome. Bye. All right, so like you said, it's a grouping problem. There's no GCF, right? So we group the first two and last two. That's how we always start these. And then we look for GCFs, right? Which is x squared, you guys told me? What's left? 3x plus 1. 3x plus 1, good. How about the second group? 2. And 3x plus 1, good. You guys are so smart. So what's my answer, Christian?
You do 3x plus 1 and then x squared plus 3.
Good. Everyone okay with that? We want those two quantities, those two binomials to be the same, which they are. That's one of our factors. And then the GCFs we pulled out is the other factor. Okay? All right, Jonah, what do we do for the second one? Okay, is there one? No. Is it a difference of squares?
No.
Is it a sum or difference of cubes?
No. Yeah.
Yeah, it is. Okay, so this is one of those sum or difference of, it's a sum of cubes because it's addition. So we have a binomial and a trinomial when we factor it. How do we get the binomial? Do what? Cube root, yes. So what's the cube root of 64x to the 6th? X to the 2nd, yeah. When you take the cube root and you have exponents, just divide the exponent by 3. What's the cube root of 125y cubed? 5. What else? Y. Yeah. Is it addition or subtraction between them? Addition, yes. Whatever the original problem is, the binomial here, they match up. So that's addition. So what's the first term of my trinomial? Danny. Okay. Oh, who was it, Andy? Or was it Chris? Say that again, Brett.
16x squared.
Close. To the 4th, yeah. You're squaring this first term to get the first term of the trinomial. So 4 squared, and then x squared squared. So that's x to the 4th. How do I get that middle term? Yeah, multiply those two together here. What's the sign going to be? Opposite. Good. Let's remember. So 4 times 5, and then x squared y. What about the sign of the third term? What did we say? Always addition. Good. And how do we get it? All right, we square that, right, Olivia? You. Yes. We square that one for this. Don't zone out on me.
Sorry.
All right, so those were 2 of what we looked at yesterday, right? Okay. So, today we're just going to go over the homework we had last night, like we did the other day, all right? So let's stay focused, and then we won't have any homework for the long weekend, all right? So, Wendy, what's number 48 problem?
Y squared plus 6y plus 9.
Thanks. So is there a GCF for this problem? No. Is it a difference of squares or sum or difference of cubes? No, because remember, those only have two terms. Is it one of those special trinomials?
No.
Could be. Because are the first and third positive perfect squares? They are.
Right.
9's a perfect square and y squared is a perfect square, right? So what did I tell you to do to check to see if it is one of those? I called it the 1, 2, 3 test, or you could call it 3, 1, 2, 3 check. How do I get number 1? Square root of y squared, right? The first term. How do I get number 2? Square root of the 9, the third term. For number 3, just multiply those two answers. Y times 3 is 3y. What are we checking now? If that answer was half the middle, which 3y is half of 6y, right? So, Lily Yoder, how do I factor it then? And since I realize it's one of those.
What?
Now that I realize it's a perfect square trinomial, or trinomial square, however you call it, how do I factor it? What's it look like when I'm done factoring it?
I don't know.
We did your homework, right?
No.
What do you have on your homework? Oh, you didn't do your homework. That's right. I'm sorry. All right. Lily Baker. Right. Number 1 in the front, whatever sign was at B. Number 2 in the back, and square it. Now, if you don't realize it is one of those, you can do it as a normal trinomial. What are the factors of 9 that add up to 6? 3 and 3. You just would write y plus 3 and y plus 3, right? Isn't that the same as y plus 3 squared? So if you don't recognize it's one of those, you can always do these as a regular trinomial. Just wanted to make sure you understood that. Fred, what's the problem for number 52?
25y squared plus 40y plus 15.
All right, is there GCF for this one? No. Is it a sum or difference of cubes or difference of squares? Now remember, those two, number 2 and number 3 on our thought process for factoring are binomials. So this is a trinomial. Could this be like the last one? One of those special trinomials? Yeah, because the first and the third are positive, perfect squares, right? So I can do my 1, 2, 3 test again. Just to make sure it is one of those. So number 1 is the square root of the first term. Number 2, the square root of the last term. Number 3, multiply those together. Is that half of the middle? Yeah. So you take number 1, put it in the front, number 2 in the back, whatever sign's in front of the B, and square it. Okay? So those two are basically the same type of problem. And I think you guys knew. Whoa. I think you guys knew that. Anyway. What's after 56? Or 52? We are 56 now, right? What's this one? Evan?
B3 plus 6 to the 4.
You mean 64?
Oh yeah, I thought the 4 just wrote like weird.
Okay. So, is that our GCF for that one? No. So what is it, Madison? It's a sum of cubes. So the tiny one, the binomial, and the bigger one, the trinomial. So what's my binomial? Anybody? B plus 4. The cube root of B cubed, the cube root of 64, and this sign is addition, so that's addition. Those match. What's the trinomial? Good. Take the first term, square it. Multiply the two terms together for the middle and opposite sign. So that makes it minus. And then the third one is always addition, and you square the second term. So 4 squared is 16. Once you recognize what that one is, they're pretty easy to do. 60? Danny, what was the problem?
1 plus y equals
Good. Thanks. All right, so this one, is there a GCF? No. Is it a difference of squares? No. It could be, if it was minus, it would be a difference of squares. Because any variable to an even power is a perfect square. Is it a sum of cubes? Any variable to a multiple of 3 power, 12 is a multiple of 3, is a perfect cube. And 1's a perfect square, a perfect cube, and all of those, because 1 times 2, whatever power is the 1. Right? So, perfect cube, binomial, trinomial. What's the cube root of 1? 1. Plus, because that's plus. What's the cube root of y to the 12? 4. Yes, 4. You just, again, divide by 3 that exponent. Wendy, what's in the middle? Or what's in the trinomial?
1 to the second
Which is 1. Good.
minus
Good.
y to the fourth
Right. 1 times y to the 4th is y to the 4th.
plus
Good.
y to the eighth.
Good. Just double the 4. You square it, right? Questions? Simple, right? All right, 64. Isabella and Neelan, what's the problem?
I think I missed that one because I go from 60 to 68.
You did skip that one. It's okay. Keely?
So I got off on my numbers, but I don't
Oh,
have
you
the
got it
one.
off, Tim? That's okay. Garrett. Oh, that's right, you did.
Oh, I have
Jonah.
it. I have it. I think I have it.
All right, go ahead, Elise.
Is it 18w to the third? Is that the one?
I don't know, is it?
Yeah.
Okay.
Okay. 18w to the third plus 15w to the second parentheses.
Oh, and that's in parentheses?
Yeah. That's what I have.
Well, you
Okay,
start-
okay.
You
Okay.
started
Plus
grouping it,
12w
right, yeah.
plus 10.
Okay. So that's the original, then your parentheses, because you started grouping, right? This is a grouping problem. Is there a GCF though? No. It looks like, if you look at the 18, 12, and 10, they're all even. If you look at the 18, 15, 12, 3 goes to all those, they have a W, but not all 4 of them have a GCF. So we group it. So what comes out of the first group? 3W squared, right? What comes out of the second group? 2. That's it, right? What's left when I pull out the 3W squared? 6W plus 5, is that what I heard? Yeah. How about the second group? Same thing, right? Is that what we want to happen? Yeah, that's what we want to happen, right? So what's my answer, Soren?
6w plus 5 times 3w squared plus 2.
Good. Any questions? That one worked out nice. We get the same binomials after we pull out our GCFs of our groups. That's our one factor, and then the GCFs we pulled out becomes our other factor. All right. Okay, moving along, 68. guys are zoning out on me. Come on. Evan, what is it?
10z to the third minus 15z to the second minus, I think 4z plus 6.
Okay, thanks. GCF to start? Not quite, is it? All right, so we're gonna group because there's 4 terms. This third term has a minus in front, so we put that inside our group. All right, so what do I pull out of the first group? 5z squared. When I divide that into those 2 terms, I get 2z minus 3, right? Now, remember, whenever that third term has that minus sign, even though they're not both minus or negative, pull out the minus sign or the negative sign. Okay? And then the 2 goes into both, and you'll get 2z minus 3 again. If you forget to pull the negative out, it'll be negative 2z plus 3. They're not the same then. Okay? So to make them the same, always pull that negative out if that third term's negative. So my answer will be the 2z minus 3, what's in both parentheses, and then the 5z squared minus 2, those GCFs we pulled out. Simple, right? $72. Fred?
81y to the fourth minus 16.
Is there a GCF? No. Is it a difference of squares? Yeah. So how do we do a difference of squares again? 1 set of parentheses, 2 sets, 1 little one, 1 big one. What do we do? 2 sets, right? Just regular size or 2, actually they're going to be 2 binomials. What goes in the front of each binomial? 9y squared, right? The square root of the first term. What goes in the back of both? 4, the square root of 16. Then what? Plus and a minus. So I'm all done, right? Evan says no. Why not?
Because they're still perfect squares.
Yeah, this is still perfect squares and a minus. This one is finished because it's addition. But this one, I can break down further. Remember, we always say factor completely. So you're right so far, but you're not finished. This one won't change. The addition, sum of squares, because you can't factor a sum of squares. But we're going to do the same thing for this difference of squares. What goes in the front of both of these? 3y, yeah, square root of the 9y squared. What goes in the back? 2, square root of the 4. And then our plus and our minus. Now we're finished. We don't have any more difference of squares left. Okay? $76. Billy Baker, what was the problem?
2x to the 6 minus 2.
Is there a GCF? Danny? What is it? 2? Yeah. So I pull the 2 out, and I get x to the 6th minus 1. Is that a difference of squares? That's the next thing we look for. Jonah's saying, yeah. You guys agree with him? He's right. Any variable with an even exponent is a perfect square. And 1 is always a perfect square, right? So that's a difference of squares. So what's the square root of x to the 6th?
X to the third.
Right. X to the 3rd. What's the square root of 1? Thanks, you guys. Then what? Plus minus all done, right?
Wrong.
Wrong, yeah. What are those binomials called? Yeah, they're cubes. So we gotta go another step. So this is when we gotta do the binomial and the trinomial. For both. Okay? So, Chris.
Yep.
What's, looking at this one.
Yep.
What goes in here?
X. Yeah, X minus 1.
Well, the binomial part, they stay the same as far as sign. Yeah, cube root both of those. Trinomial part.
The X to the second
Yeah.
minus
Yep.
1. 1x to 1.
Yeah.
And then plus
It's always plus.
1.
Yeah. So again, we take that first term and square it to get the x squared. To get the middle term, we go x times 1 and change the sign. And then the last term, we square the 1. Okay? Garrett, what goes over here with this one? Right. Cube root of those are x and 1 and then minus, because this started out minus. Then what goes here?
9x squared
Yeah, x squared.
minus
If this is minus
plus
plus x, yeah, or 1x, it doesn't matter. Plus 1, yeah. So they're really similar. Questions? So this had 5 factors. That's okay. Understanding this? Your quiz, well, again, sometimes our homework's tougher than our quiz. Okay? If you're understanding these last few, you got it down. What was that, 76? So we're at 80. So Olivia, what's number 80? Wendy?
I don't have it.
Okay. Who's got it? Kayla, you got it?
No.
Oh, that's what you got on. Fred? Brian?
x y plus 20y minus 15x.
Minus 15x?
Yeah.
Minus 60? Thanks. GCF?
Maybe if you
5.
group.
Yeah, 5, right? 5 goes in all 4 of them, don't they? Doesn't it, I guess? So we got xy plus 20y. Oops, not 20. Sorry. What should it be? 4y, yep. Minus 3x minus 12. It's 5 times 12, 60. Yeah. All right. Now what do we do after we took out the 5? Because there's 4 of them. Group, right? I heard somebody saying. We'll group those two, little plus sign in there. Remember, 5's still there. Extend my page. All right, what can I pull out of that group? A y, right? Well, let's put this, let's still keep this going for now. Pull y out, and then we've got, what, x plus 4? What comes out of here? Negative 3. And I get x plus 4 again, don't I? Is that working out good? Okay, Jonah, what's the answer?
Would be 5. And then y minus 3. And then x plus 1.
Good. You guys see that? So just keep bringing the 5 along once you pull it out. Don't forget about it. That's what some kids do sometimes. Questions? So that one had a GCF and all 4 terms. 84. Evan?
16x squared plus 81.
Is there a GCF? No. Is it a difference of squares? No. It's a sum of squares, right? So is there cubes in there? No. So those are the only things we look for when it's got 2 terms, right? So can we factor it? No. So that one's not factorable. That happens sometimes. Last one. Fred, what is it?
A squared plus A plus B minus B squared.
Is there a GCF? No. So I should group, right? What do we usually do when we group? First 2, last 2. Will that work? I can pull an A out and a B out. Does that help me? You guys see that? It's not going to be the same. Could I change the order and group it? First 2, last 2. Can I do that first group? What is that first group? A difference of squares, right? A plus B, A minus B, right? Think of this as one term and another term. Is there a GCF? There's something common to both. A plus B, right? All right, when I divide this left rectangle by A plus B, what's the answer? A minus B. When I divide this rectangle by A plus B, what's left? 1. So that was kind of a weird looking one. Had to switch up the order and stuff. Any questions? Are we getting better at factoring? That's the goal. Did you get better this week? Yes? No? Yes, I think you did too. All right, so good job on